cancel this out. Over here on the right, go to device type and then IO link. Double click that. So now you have the IO link master in the project. You can check to make sure you have connection to it. So now you see the pauses. You can disconnect so you know you're connected. If you go here and do scan topology, there's our ODT 3C. All right, now we select the device and connect to it and hit online parameters. Okay, and from here, it takes a minute to get all the parameters uploaded, but you'll see at the first screen or the first section is the identification. Here you'll get the basic information of the sensor that's in the IODD file, the product name, the part ID, the serial number, firmware version, that type of stuff. Parameters about the IO link connection. If you wanted to look at the data sheet from here, you can. And then there's also a tool. This is kind of an instructions for how to work with Sensor Studio and the IO Link Master. On the configuration tab, this is where you, like I'll use George's example for the interlocks opportunity. Here you can change the functions of the different output pins, what pin is controlling, or what set points is controlling which pin. And then in the individual set points, you can set up the limit. So say for this output here, you want to see an object within a range or just a single set point, single point. So if it's single point, it's going to use this SP1 set point. You can change what that set point is. So if it sees an object 50 millimeters from the sensor, it's going to activate this SSC, which is configured on pin 4 of the sensor. And then there's a lot of other options. I won't go through all these in detail, but you can do it single point, window, 2-point.
Christian, I have a question.
Yes, sir.
I wasn't getting SP2. Like, if you're in single point mode, does that mean that the 70 under the SP2 is inactive, or?
Yeah, it's using the 50. It's using SP1.
Okay. All right. Thanks.
So I'll tell you what, let me. Okay. So now you should see. Okay. So right now I'm not going to touch any of the settings because I had it set up for this little demo. But what I want to do now is show you the If you go to the process tab and you hit play here, this will start to pull the data, the real-time process data from the sensor. And there's several different lines on here. The first line, the red line, that's the actual measurement data. And you can see that the little target has stopped because I have the ODT 3C sending a output to the controller for this drive that'll stop when it reaches a 40 millimeter distance. And that's configured on SP1. So basically it did what it was supposed to. It's set to 40 millimeters. The output went low and it stopped the device. So if I start it back up again, you'll see this bit went high and now the distance is increasing. Now it's 122 millimeters away, 134, and it's going to return back. And then once it reaches that 40 millimeters, it should stop again. So you can kind of see real time the measurements and the bit state. And that's strange. Not all the sensors are going to have a diagram like this. Some will just have like state representation, which will be just values. And this is kind of the data that'll be passed and available for like a PLC, for example, if the IO-Link master's talking Ethernet IP, and the customer like Intralocks could be monitoring this value, and when it does that teach process, it looks at this value and says, oh, okay, the distance from the sensor to the conveyor is whatever the distance may be, 110 millimeters. Now use this value in the set point, or use that value plus 20 millimeters in the set point. And these values are being set just like you would if you were using the teach button on the device. So real simple. Any questions so far with the process data or the configuration? One thing I really like about having this IO-Link master is it's a real quick way to see what parameters are available for that sensor. You could always go and look at the documentation and read it, and then use the teach button or the onboard controls to set those parameters. But here you have really easily, oh, okay, I can change the function of pin 1 or pin 2 to, no function, or use that as a warning or whatever. And then in each SSC, you can change the values at which the states or the outputs change. You could also change on this. Is it going to be normally open or normally closed? You always have to press play if you want to get the process data showing on the diagram. There you see the bit change. So let's say I want to change, I don't want my target to get 40 millimeters away. I want it to change directions when it's 80 millimeters away. So I could stop this, go to the configuration, and set this to 80. And then I'll press this download to parameters, download to device, and go back to the process data. You see this blue line here increased. So now if I start the cyclic update, let's see, now my threshold is up to 80, and that output should change, and the target will go the other way. It didn't. I changed it on the wrong. Sorry. You always have to stop this if you want to change the configuration. If I change it on the pin 4, download the device, start this. There we go. Now it should stop right here at 80 and go back. There we go. Now it's going at 80, where before it would go till it was 40 millimeters from the sensor and then turn around. So, real quick demo of the online data, the process data, and the configuration. The last tab, diagnostics. Here, there's some event. It records some events that you could look at, the temperature data, diagnostics if there's any errors. So this is how many events, how many state changes have occurred. Then you can do things like factory reset, do a device reboot, back in inbox. Like, not sure what the difference with that and the factory reset would be, but different things you can do on the diagnostics. Are there any questions?
So Christian, once, let's say a customer has this sensor and they're testing one sensor out like this using this format, this IO-Link master. Once they get it configured exactly how they need to have it for this process, the idea is what they save this configuration, right?
Yeah.
And just show them how, like, once they get to a configuration, how you save it, and it's how it's saved in that IODD file or whatever.
So this will be a Sensor Studio project. Let's see. I don't want to say this is a real IO-Link master, but on a like our MD798, there the device, the parameters will be stored on that device. This USB IO-Link master, it doesn't store any parameters. So if you just disconnect the sensor and plug it back in, that the USB IO-Link master is not going to know to send the parameters out to that device. But the 798 can do that.
But so you've set the parameters in this program, and then the parameters on that sensor are set, right? So
yes.
Then somebody might take this sensor, and then how would they mass duplicate this, for, let's say they had hundreds of these sensors that they needed to configure.
They would do that from the IO-Link master, yeah.
And they would do that by connecting this sensor to that third party IO. It could be ours.
Yeah.
It could be.
Yes. Yeah. They would just connect it to the port that is assigned to that type of device. So then the device, once that IO-Link master sees that device, it'll then send the configuration parameters to it.
Right.
And and that avoids like what George was talking about, where they had customers that would change out a sensor and not know that sensor needed to have certain parameters, and then they didn't know why the machine wasn't running. And so the IO-Link master takes that part out of the equation, and now the maintenance people can change the sensor, and the IO-Link master is smart enough to then send the values out to that new sensor.
So I think that's definitely one big benefit of this. One other example we had where we captured some business was, it was an intralogistics application. It was actually ended up being for Amazon, was the end user, and the application initially was utilizing two diffuse single switching point sensors to tell basically that it was a bag for like that parcels go in. So it was like just imagine like a mail bag that parcels go in. So one of the diffuse sensors detected if the bag was there. The second diffuse sensor detected if the bag was full, if it was full of the parcels. And so we provided a solution with a dual switching point diffuse sensor where they could do it all with one sensor. And so what they did, how we looked at it is we took an IO-Link version of that sensor, or IO-Link capable version. We used this software to kind of set it up and configure it. They configured not only kind of the distances for the switching points. They configured the normally open, normally closed for each switching point, which they had to configure very specifically for their IO. And then once they did all that and had the configuration kind of finalized, they could have implemented, like we said, a solution where that sensor trained the 1,000 or 2,000 other sensors from the master, right? But another thing that we did was we took that sensor configuration, and we told them, one of our selling points was, we said, okay, you have this customized configuration. We can mass produce these sensors with those parameters already on them. So all you have to do is plug it in and go, right? So that's another option. I mean, that doesn't utilize that IO link, that George was talking about, but it's another way of a customer being able to go in here, do all the parameters via IO link, and then possibly another way to kind of offer an additional customized, set of parameters on a sensor that they can order.
That's right. So I was just going to try and hook up the GSX real fast and show you what that looks like.
While you're doing that, Christian, this is Aaron. I'll just offer a couple points on IO-Link. One is, if you haven't been talking about IO-Link, you're pretty late to the game. Balluff has been running around for the last 8 years selling everything IO-Link under the sun. So light curtains, every kind of device you can imagine, from the masters, the hubs, all the sensors, the light stacks, just you name it, they've had it. So be looking for it. It's out there. And I just say a couple words on how to think about IO-Link in terms of, if you're not familiar with IO-Link and the IODD files and all the things that it can do. And George mentioned that it's not a bus. He's right. This is not a bus system per se, although a lot of people are selling it as a bus system now. But think of IO-Link as the equivalent of a USB device, like your mouse. And once you install the mouse and the drivers, whenever you plug it back in, it recognizes it and it works. And at that level, that's basically what IO-Link is doing. It allows you to operate a lot of devices with a lot of parameters, but have it instantly recognized and easily configurable. And a couple of the other advantages that you get with IO-Link devices is, obviously, you have a lot of parameters that you can use. The transfer of these parameters to the PLC and then ultimately up to a cloud storage device, or being analyzed, MQTT, all these other terms you hear. It's easier to process this data through those paths with an IO-Link enabled device. That's why a lot of people are really seeing advantages to it. And traditionally, when you had in the past analog sensors, now you can use IO-Link enabled digital devices and get rid of all the analog concerns, like having to have shielded cables, or strange links or ground loops, or all these other problems that are created when you have the need for shielded products. So you're automatically switching basically to a digital conversion right at the device, right at the sensor or whatever device it is that's being looked at. Do become familiar with the IO-Link Consortium webpage, which I think is io-link.com, and how to look up IODD files there. Lloyd's has got a whole library there. I know we probably have them online, and it looks like we've got them in the studio as well. But customers will ask, where do I get the IODD file? And those are the two easiest places to typically get the IODD files. It's either going to be online with us in our own web, or at the IO-Link Consortium page, and it's listed as a vendor there. Then they just select the right IODD file to download. I think that's all I wanted to add to it.
All right. Thanks a lot, Aaron. So I just literally just took the 3C sensor off and plugged in the GSX, and then did the same process that I showed you guys, how to add the device, scan the topology and add the device. And now you can see this is the first time I connected the GSX to this IO-Link master, so I wasn't sure what we were going to see, but you have the state the state diagram, the measurements, it looks like you're seeing amplitude. That must be the signal strength coming back to the transmitter, to the receiver. So I've got some labels here that I'm trying to run through it, and you can see if I do it slow enough, you can see that red line breaking the 2000 threshold down on the bottom graph, and that's the gap in between each label. So as the signal's low, it sees that label. The problem is the refresh rate on Sensor Studio is not fast enough, so I got to do it kind of slow. There's one. There's a gap. There's a gap. Should show up. Yeah, there you go. And so you can see then also for each gap, I just took the label out, so you'll see the amplitude of the receiver's really high now. But on each gap, that bit changed. There's a lot of parameters here compared to the ODT3C. Yeah, you could basically the same thing that you could do on the controls on the sensor, you can do here, and probably a little bit more. Basically, you can change ultrasonic auto level control. I know you can enable with a combination of button presses, and you can, let's see, should be able to manually set. Yeah, here you could say, okay, I want this to be optical or ultrasonic, and if you do the automatic teach, the sensor will decide that for you. But here you can force it to one or the other, and then save it in using Sensor Studio. But these are all parameters again that can be set and saved in the IO-Link master. And then if a GSX14 fails and the maintenance team replaces it, they don't need to go in and press all the different keystrokes to get the settings exactly like that failed unit was set at. All right, any questions? If you guys would, take some sensors, connect it, do it yourself, play with it, I think that's going to be the best way to reinforce it. I know for myself, if I just sit through an online webinar and don't practice it, then I'm going to forget it within a week. So, but you will have that reference guide I'll send out after this, so you can reference back to it. But go ahead and give it a shot, and let me know. Message me if you have any issues, and I can log in with you and see what's going on. If you have a connection issue, or if you have any questions specifically about a device, just reach out.
And I think I'll add one more thing. I think, as the second half of this year and into next year, I mean, we are going to be hunting hopefully very large PC1 opportunities, right? And some very large PC1 opportunities are going to be what I'll say are very basic commodity type sensors like PRK, global beam PRKs, but then some that require applications where the switching point has to be taught, the normally open, normally closed has to be assigned, those kind of things. I mean, IO-Link is a huge selling point for that, even if they don't implement IO-Link within their whole system, because it's a tool that allows them to kind of quickly program, potentially thousands of sensors, relatively quickly, as opposed to some guy pushing a teach button, 1,000 different times. So it's definitely a tool. I mean, George, Christian know what they're doing. We have experts in Germany that know what they're doing. So definitely don't be afraid to present it. Be comfortable enough where you can present the benefits of it to these guys, and use it as a way to hopefully land some high volume PC1 business for sure.
Awesome. Thank you, Jared. Well, if there's no other questions, then I hope everybody has a great weekend, and reach out if you have any IO-Link questions.
I got something I'd just like to go over. Take another couple of minutes.
Okay.
I'm going to share my screen here, so just to be sure. Okay, I'm on